Hello, quantitative literacy students. This is me, Gary Parker. We're going to play a little bit with percentages today. So I'm going to share my screen with you so we can do some work. All right, so just a reminder about percents. Per literally means divide by. And cent means 100. So the percent symbol, like 20%, literally means 20 divided by 100. From here, we could do a few things. We could whip it out in a calculator. We could realize that dividing by 100 is going to shift the decimal place of 20 2 places to the left, making it smaller because we're dividing by a big number. So we get 0.2 when we do that. Plugging this into a calculator is going to give us that same thing. Most calculators output decimals. We could also choose to take that 20% and just reduce that fraction. So here I might realize that 10 goes into the top and bottom, so that's 2/10. And these are both even, so I can divide 2 into the top and bottom. 2 goes into 2 once, and then a 10 5 times. So 20% as a reduced fraction would be 1/5. Reminder about fractions and decimals, most of us look at this right here and say 0.2. That's slang. The proper way to read that is 2/10, and you can then reduce that down. Changing a fraction to a decimal involves actually carrying out the division, which you could do with a calculator or long division if you like. I'm not going to go over long division here. So just by noticing that a percent symbol means divide by 100, I can always convert a percent to a regular number. A regular number is either a decimal, like 2/10, or a reduced fraction, like 1/5. Sometimes we like to go the other way. We like to take a number, like 3/4, and we want to convert that to a percent. So the trick there to convert that to a percent is to realize, well, that's the opposite of what we were doing here. So if changing percent to a number is dividing by 100, then changing a regular number to a percent must be multiplying by 100. And that's most of the picture. The trick is that we're multiplying by 100%. If you think about 100% as a regular number, it's just 1, right? It's 100 out of 100. So we're not really changing the value of this number, we're just displaying it differently. Now from here, I could either plug this part into my calculator and get an answer, or I could just clean it up by hand. So you're all good with the calculators, I'll let you do that. If I'm going to convert this by hand, I'm multiplying numbers. I would view that as a fraction. And so 3 times 100 is 300. 4 times 1 is 4. And then let's do a little long division. I said I wasn't going to, but apparently I lied. It's kind of fun. So 4 doesn't go into 3, but it goes into 30 7 times. 7 times 4 is 28. Subtracting, I get a 2, bring down the 0. 4 goes into 20 5 times. 5 times 4 is 20, giving us a 0 remainder. Now, we're not always going to get a 0 remainder, but we do here. And so what I found is that 3/4 of 100 is 75. The percent symbol is hanging on, so it's 75%. So to convert a regular number to a percent, the trick is multiply by 100% and then clean it up, the multiply by 100, leaving the percent symbol hanging on. So now we're just going to do some work with percentages. So let's take a look at something that's like the worksheet problem. So on your worksheet, on number 4, you were asked to consider this bit of information here about total number of violent incidents at 2 different police precincts and the number of those violent incidents that involved weapons. So we had 5 involving weapons here, 18 there. There were 25 total in the first precinct, 12 in the other. I'm going to do a similar problem. What I'm going to do is something that relates to me as a teacher is I'm picking a couple different of my classes and the number of students in each class that do their homework on time. So at first glance, in my first class, there's only 9 that do their homework on time. There's 15 in the second class. So it looks like there's more students in the second class that do their homework on time. However, if we think percentages, we might get a slightly different view of this situation. So let's put this in a piece of paper so we can play with it. So again, at first glance, there are more students in the second class. However, the second class also has more total students. Okay? So if I think about this fractionally, 9 out of 12 students in my first class do their homework on time. And this, I could do a couple of things. I could just plug it into my calculator, get an answer. I could reduce it as a fraction. So I'm kind of curious about it as a percentage. And so just for fun, I'm going to plug it into a calculator and see what the calculator gives me. So remember, we're changing a number to a percent, so we have to multiply. So I'm going to use my Google calculator and say, what is 9/12 of, so that's a times 100, and that tells me 75. So back here, if I just write what my calculator told me, that number appears to be 75%. So 75% of my first period class does their homework on time. If I switch to do the second period class, that is 15 out of 35. Now, what strikes me as interesting here is 15 is just under half. Half is 50%, so it looks like less than half of my second period class are doing their homework on time, which sheds not quite a good light on that class. Just double check on my calculator. So what is 15 divided by 35 and then times 100 to convert to a percent? And I get a slightly more interesting number. Let's round to the nearest tenth of a percent. So it'd be, or maybe whole percent, we could call it 43% about. So this, I'm gonna write a wavy equals to say it's about, what was it again, 43%. So although there's more people in the second period class doing their homework, it turns out that's less than half of the class is doing their homework on time. So at this moment, at first, I was more worried about my morning class because there were less people, but it was a higher percentage of the class. So it looks like my second period class is in bigger trouble there because the students aren't doing their homework on time. So a percent can shade a different light on a problem than just straight numbers. And that's what you're asked to consider in that law enforcement problem in number 4. So I'll let you go play with that. Next kind of interesting thing is percent markup, percent markdown types of problems. And so I'm going to go over to the spreadsheet and do some work in the spreadsheet here. And again, I could have done those same calculations here by just asking, and this one's a little easier. Just say, hey, what is this number divided by that number? And remember, spreadsheets are pretty much point and click. To do a calculation, type equals. If I want to do a division, I click on the numerator first, hit the slash to divide, and then the denominator and hit enter. And it says 0.75, and I can ask the computer to format that as a percentage for me, and it says it's 75%. It's showing more decimals than I care to see, so I can always decrease or increase those. I usually like to see 1 decimal point with percentages, but it just kind of depends on the problem. Same idea here, equals numerator, students who do homework on time, divided by total number of students. And then I can click back on it and say, please format that as a percent for me. And I can drop it down to decimal place. So again, almost 43%. All right, let's play with sale price. So let's suppose there is a 25% off sale. So I just picked a regular price of $74.99, about 75 bucks, percent off. Let's say 25%, and I can just type 25 with the percent symbol. The computer understands what I'm talking about. To calculate the amount off, I just want to know what is 25% of this number right here? And that's just a straight multiplication problem. So I can just say equals, what is 25% times that amount right there? And the computer's going to tell me it's $18.75. Now the sale price can be found by just taking the original price and subtracting the amount off. But there's a slightly different way to look at it. So if we're getting 25% off, that means we're going to pay for the sale. What's left? Well, original price is 100%. We're taking 25% off. That's going to leave 75%. So I can just write a formula that says that. Now, 100% is a 1. So if I just take 1 minus that percentage, then I should be able to get the amount I pay. Now, a slightly different way to look at this is to not even worry about the amount off, because I don't really care what that is. I just want to know what I pay. So I can write the amount of the sale price again, sale price. And I can calculate that by just simply taking equals the percent I pay times the regular price. And that's going to give me, what did I do wrong? Something wrong. I must have hit times. I forgot to hit times. Okay. Try that again. Equals times, there we go. And then I get the same amount I had before, 624. So a couple of different ways to look at it. So sometimes it's nice to think about the situation, not on the amount off or the amount increase, but out of 100%. So if it's a percent decrease, like a percent off, then I do 100% minus, and 100% is 1 as a regular number. So 1 minus that percentage gives me what I want. And I can plug in anything I want. So now I have like a quick calculator here. So maybe it was $95.80, and then I would end up paying $71.80. Right? Other things I can do to adjust my spreadsheet, and this is the nice thing about spreadsheets, is you can just tweak numbers if you use them in formulas. So for example, these two numbers depend on the 25%, as does that one and that one. So if somebody said, hey, it's actually a 70% off sale, I can just go in here and type 70, and it will recalculate everything for me. So what's the important part here? The moral of this lesson is when you have a percent off, you can always consider the percent remaining. And the percent remaining is always going to be 100% minus the percent off. And that's usually the more relevant number for us. So if I'm shopping with my daughters and there's a 25% off sale, I'm thinking that means I pay 75%. So when my daughter shows me a price tag, I think, oh, what's 75%? What's 3/4 of that? And I can usually estimate that to get a rough idea about what we're going to actually pay. And that's nice. Remember also, 100% is really 1 as a number, right? Because 100%, that's 0 right there, is 100. Percent symbol means divide by 100. It's really a 1. So when I calculate percent remaining, that's really 1 minus the percent off on a calculator or a spreadsheet. Okay. All right. That's about the hardest part of that worksheet. So have fun, do good work, and I will see you soon. Bye.